Hello, so the aim of this experiment is to construct an electric train out of the given materials. The materials used in this design includes a long string of uncoated copper wire, 2 neodymium magnets, 1 AA battery, and a long plastic tube. The overall process is to place an electromagnetic train made of magnets and battery into a copper wire track to observe it move. The first step is to coil up the copper wire using a plastic tube provided. This was created so when the train is put inside the coils, it can create an electrical current to flow through the copper wire. A magnetic field is also created by a solenoid, which is simply a coil of wire wrapped in a tightly packed helix shape. When a solenoid is connected to a voltage source, a current I is provided along the wire. The current, which is going through the loop wire, results in a constant, uniform magnetic field through the center of the coil of the wire. The resultant magnetic field lines are shown by blue lines in the diagram. And then therefore, an electric magnet is created. The strength of the magnetic field is proportional to both the number of turns of wire per unit length, and the strength of the current passing through. Due to this magnetic field having its own north and south poles, it pushes the train along the track. To make the train, the magnets will need to be placed on each side of the battery with like poles facing inwards. This allows the force to be in the same direction and to combine, otherwise the forces will cancel out and the train will not move. The two magnets are automatically at the ends of the generated magnetic field, in which the field is divergent, therefore a force is then exerted onto the magnets. When the magnets are attached to either end of the battery and resting on the uninsulated copper wire, a local circuit is then made along the length of the battery. The circuit is made from the positive terminal of the battery into the magnets, through the copper wire of the solenoid and back into the magnets on the negative terminal of the battery. So when the magnetic fields interact with the magnetic field created by the magnets, it is able to push the battery through the coil. However, as the train moves, it also creates a new localized circuit that perpetuates the motion. In order to show that the current carrying wire does generate around the wire, we use Ampere's right-hand rule. This process involves pointing the thumb of your hand in the direction of the current along the wire, and then curl your fingers inwards. The direction of your curled fingers gives the direction of the magnetic field, shown by the red lines. The magnetic field radiates outwards in a circle, with the field strength decreasing as you go farther from the current carrying wire. This information can then be used to confirm the magnetic field lines for the solenoid. By following the curve of the solenoid with your thumb, we can confirm that the direction of the magnetic field will always be through the center of the solenoid. By conducting this project, we were able to gain a better understanding of how the train and copper wire function together and the whole concept of electromagnetism overall.